of information technologies to improve the performance and profitabilities in all segments of the oil and gas industry. Her career includes drilling, reservoir operations, process, and facilities engineering disciplines for Chevron and Mobil Oil. At OSIsoft, she's been focusing on analytics, cloud, IoT, AI, and machine learning, leveraging the growth and smart centers of business intelligence, analytical methods, and using OSIsoft systems as a contextual infrastructure. She holds a Bachelor's of Science in Chemical Engineer and an MBA in International Business. Um, Cindy, welcome. And you're muted. You are still muted.
How about now?
You're good.
Fantastic. Thank you. Sorry about that. I couldn't figure out how to unmute it once I got back to there. Thank you, Tiffany, and welcome. Thank you, everyone, for joining us today. The topic I'm going to cover today is saving miles and money. Apache uses the OSIsoft PI system in Esri to boost safety, cut windshield time, and reduce cost. This presentation is an abbreviated presentation that was given at one of our Pi Worlds. Kelly Sherrill of Apache actually presented this, and his title was Enabling Business Transformation Journey at Apache with the Pi system as a strategic OT infrastructure and analytics platform. The part of the presentation I'm going to focus on is the part where Esri is center. The link to the actual presentation is on our website, and I've provided it here, and you'll receive these slides, so you could just click on that and listen to the full presentation. Many of you might know Apache, but we're going to focus on the U.S. operations of Apache today. They have about 3.1 million gross acres in the Permian Basin, 1.8 million in the Anadarko Basin in Eagle Ford, and they have the fairly new area of development in Alpine, and they call the Alpine High. They have about 19,000 wells that they've drilled there, and about 70 new wells a year are drilled. So we're going to focus on some of the key things that they've been able to do. So they went into Pi and our asset framework structure, and that is really their language of Pi. They're very used to Signet, which is one of their sources of data. I'm going to share a little bit about the Pi system so you can understand how the Pi underpins the Esri detail that you'll see in a few minutes. So all their assets, whether it be a gas meter, a tank, or a well, are connected to the Pi asset framework, which mimics the operation and allows them to look at their asset framework in the details on the far right there, whether it be well ID, runtime, bottom hole pressure, pressures in general, temperature, and allows them really not to have to know a tag or a number or a tag name. They can actually go to bottom hole pressure and find that piece of information, really enabling their organization to understand the language of how they run their operations. So a little bit about the perspectives on Pi and how they use it. One of the key things is if you look on the right side, that's a gas lift well, and that's the compressor, and they actually have an asset framework that depicts that actual operation of that compressor and delivering gas to that gas well, to that gas lifted well. As well as the compressors, all the compressors in the field, they have all the stoplight information on those compressors that they can look at any time on any place of any compressor across their operation. As well, they have a way in which they can look at their tanks and see if their tanks are full or not full. And they actually have calculations in the background that are in Pi AF that allow them to determine when that tank needs to either be the logistics of a truck showing up for hauling the oil away or the water away, or injected into a saltwater disposal well. They can actually calculate how long that is. And instead of having to worry about the alarms and containment and things of that sort for any spills, they can actually have it all logistically managed that way. And PI underpins that part of it. So they have a lot of data coming in, whether it be from drilling, completions, facilities, the SCADA data. The PI system sits on top of all that data to help them understand first the AF structure and allowing them to understand the process. This is a vision screen about some of the drilling data and completions data. This is an Esri screen showing them the routes and the systems in the field. Data Link is one of their tools that they use a lot of, and as well some of the other process diagrams. This user community is allowed then to be able to see everything, whether it be analytics, visualization, engineering, process management. All those types of things give them all the detail in which to do this, whether they're looking at production or accounting as well, really allowing Pi to underpin the entire Apache ecosystem. As I mentioned, Signet is part of the data from the wells and the SCADA system. They have all the wells managed there. Avocet is their allocation engine. As you can see on the far right, the Esri ArcGIS map of where their wells are and what those wells are producing. Different process analysis, wonder where is in their gas plants. As well, they look at Pi Vision and look at individual, whether it be an ESP or a beam pump, and you can see all that. But again, that's how it's all managed, as Pi is underneath feeding the data up to these additional systems. The one thing I didn't mention was their remote operations center, which is the key to what all this is. And this is their Houston remote operations center. And this has been really key during COVID, with being able to have access to all their data through their handheld or in a remote operations center. So for instance, their rod lift system for artificial lift. Here's all the parameters they measure, the last load on that well, how many strokes per minute, how full the pumps are as they're lifting the fluids. This allows them to do all their pump off control and know how long it takes for them to produce what the volume of oil or gas that they're going to produce on that particular well through these Pi Vision screens. And that all that asset data is readily available, since they built this template of how a rod lift well looks in terms of all the details of that rod lift. The other part that I wanted to share with you is, again, an Esri screen, and this is the Pi data is on the left and the Esri screen is on the right. That Pi data is underneath those dots. So it's actually pushing data in to do three types of analysis. Offset wells monitoring, so you can monitor if there's any communication coming from a frac job of an offset well being fracked. The analysis of the fracture, any calculated information, and imports of data, and I'll show you each of those. So here's your offset wells. You could identify those offset wells and their reservoir and determine if the pink gets larger, it means that there's some communication between the wells. You can look at individual frac jobs. So each frac job that's being performed can be seen there on the bottom line, as well as the detail up on the top left, and you can compare them to one another. You can look at all the completion data that's relevant at that point in time. Any alarms or things that are going awry will show up there. As well, this is a set of Python code, and in this case, they're bringing in over 10 million rows of data to calculate event frames, such as treating pressures, any of the shifts in treating pressure, and each of the different frac jobs, so they can look at all of them and compare and contrast them all. And then display them in a graphical representation showing the pressure buildup as well as each of the fracs. That is all shown back onto the Esri maps. So this shows them how, when you're pumping the frac job, even though you stop pumping, there's still reverberation in the wellbore, and this actually shows them the true end of the frac job. So those points are different ends of each section of the fracking that they're doing. The remote operations center is where all of this is viewed and analyzed and provide input and details to the people running those jobs. So not only are they looking at it on the truck, on the location, they're also looking at it in this remote operations center, which is in the field office. So when they went out to do this, their thought process was they wanted to help the operations staff make better decisions, being able to visualize the data and monitor it. They wanted to increase their uptime on their wells and productivity levels, allowing data systems and technologies to be integrated and truly visualizing that operational data in a way in which they could see, how can I get more out of this particular set of wells? Thirdly, they wanted to increase response time to operational issues, whether it be from analytics for your field engineers doing some sort of analytic, or being proactive in how they do their maintenance of their programs, of maintaining their wells or pumps or the systems in the field. But most importantly of all, they wanted to improve their safety. They wanted to build a system that had some redundancy and built-in failover support for the operations and the field personnel. Here's an example of what they're looking at every day. And again, this is an Esri map. And on there, the green dots are wells. The red dots are alarms and routes to those alarms. And you can see that the left is the day view, the right is the night view. And what they were doing here is setting it up so they could actually have access to all the personnel and the wells and the alarms, prioritize all the alarms, send the right person with the right skills to the right location. And that was really the objective of this, was to send the right people out to do the things and quit doing the milk runs or operator routes that we're also used to having operators do. So in summary, they would have visualization. In other words, they would be viewing live facility data and any of the alarms that they would be seeing, where all the vehicles were, not only their vehicles, but what type of person was in that vehicle, whether it was an operator or pumper themselves, whether it was a mechanic, electrician, or whether it was some contract personnel that were in location that were also accessible to them, and looking at all the assets in a whole as a whole. Secondly, to analyze. They wanted to analyze the details of the facilities, pressure rates, volumes, temperatures, being able to understand how full those tanks were, how much time there was until they needed to have that truck there to unload that tank. They wanted to know facility history to be able to project when the next time they needed someone there or someone there to offload the water. And third, to respond, to prioritize and acknowledge these alarms, to understand what kind of person, in terms of their skills, needed to respond to that particular alarm or alert. So, looking at that as a group, they not only had facilities as a whole in terms of what alarm states they were in, they actually could drill down to the individual components in the facility, whether it was a saltwater disposal well, whether it was a particular well, whether it was a meter, a tank, a gas lift compressor, whatever component it was, they could actually look and drill down into that specific piece of information. And then look and analyze the tank production trends, as well as the pump off control strokes and how full those pumps were, to being able to deliver fluid to those tanks. So overall, they could look at all these things, acknowledge those alarms, prioritize those alarms for the field personnel, and most importantly, communicate with those field persons. So in other words, they could identify both the nearest driver, they knew what the driver's phone number was, and they could actually connect to them on Skype and say, hey, I know this isn't your well particularly, but this well is on alarm and it needs someone, and you're the closest person. Could you go and see that? And lastly, dispatch emergency personnel. If there was an emergency, they could easily and quickly do that. By being able to connect to these people, it saved them tons and tons of miles. Imagine if your route was 50 miles every day, and you only had to go and travel 7 of those miles in a day instead of 50. Imagine the number of wells with 50 plus operators that you could do this. And realize too that Apache has 25,000 miles of lease roads in which they're covering. And once you start looking at all those particular safety issues and savings, they were really pleased with the outcome of this. So the combination of OSI Pi, being able to look at not only the nearest vehicle and the information on that particular well, you could look at all the curves in terms of what was the past production, what's the current production, why was this well off the last time, does it need to have the does it need a pump repaired so you could send an electrician, or does it need the stuffing box repacked? The operator could go do that. Those are the things that you would send the right people to the right places to do the right things. So kind of in summary, what Apache set out to do was to go digital. This was a huge undertaking and change in their organization. Going digital to them meant harnessing the value of operational data in drilling, completions, and production, with the intent of lowering the costs of productions and time to first oil, increasing their EBITDA, and continuing their leadership in health, safety, and environmental. So their challenge was they had this OT data from their Signet systems, but it really wasn't able to be used by a multitude of people. They were drilling over 80 wells a year. They'd had diverse tag and asset naming, many applications and solutions, and truly Excel hell in a lot of cases with how they were trying to manage all these multiple spreadsheets. So they started on this journey of installing an enterprise PI system, augmenting both their Signet and Wonderware SCADA environments to go digital, evolving into these PI-AF templates, which were easy to deploy because they were templatized. They used PI Vision to address key visualization requirements because it was a drag and drop capability. They migrated to this remote operations center to enable not only remote operations, but remote access by a multitude of personnel and limiting the number of people that had to go to a well each day. Overall, being able to standardize on their OT infrastructure, improving the performance of drilling completions and production. They reduced downtime, reduced drive time, improved safety, and saved many, many dollars in the process. And that's it. I believe that I can answer a few questions if someone would like to ask me a question.
Thanks, Cindy. I actually received a question. The person asked, what else have they done since this presentation?
So Apache has been able to, let me go back to, so on this nearest personnel, they've been able to integrate workforce into the process to bring in all of their contractors into the story as well. So not just their own personnel, but they can actually optimize how they utilize their contractors in a very efficient manner by assigning them work orders and things that they can do to help augment what their field personnel are already doing. So it's a great addition to the story.
Thank you.
Thank you for the question.
Yeah, and also, guys, if you have any questions, just unmute yourself and feel free to ask your question. And then when you're done, you can just mute yourself back.
Hi, Cindy. This is Paul with Esri. I have a question. This is a pretty impressive system. How long did they take to kind of, put it all together?
It's amazing how quick they did this. So they were able to initially do this. They had to, get equipment, and there was some equipment timing and stuff that went into this. Like a lot of the screens took a little bit longer than they expected. So it was about 6 months to get it all, the big Houston one done. But once they got the Houston one done, the others they could do in a couple, 3 weeks for each of the other field locations. So really, if you were to do it today, because we can get the screens more readily because they're more available now, it wouldn't take you more than about 6 weeks to do the first one.
Wow. Okay, thank
Great
you.
question, Paul. Any other questions?
Okay. Well, thank you so much, Cindy.
Thank you. Thank you all very much.
Okay. So for our next speaker, we have Samuel Cook. Sam is with Esri. He's a geospatial analyst and developer with a background in defense and intelligence. He holds a master in geospatial intelligence from Penn State University. Before coming to Esri, Sam was with the Department of Defense. At Esri, Sam provides technical assistance to businesses, partners in the Natural Resources Division. His current role emphasizes the development, deployment, and evangelizing of spatial machine learning and artificial intelligence body of knowledge to users of Esri's technology, achieving greater success. Sam? And you're muted as well.
All right. Can everybody hear me?
Yes, you're good.
Sweet. Yeah, so thanks for the introduction, Tiffany. Like she said, I'm a solutions engineer at Esri, and today I'm going to be covering kind of a general introduction to artificial intelligence, what we mean when we say the phrase GeoAI, and then kind of some of the components, workflows, tools that are involved in GeoAI, along with some use cases and the value that you can get out of kind of using these techniques in your business. So this is going to be the world's kind of quickest artificial intelligence introduction. I'm going to try and introduce some of the terminology in different categories. It's important to note that AI is everywhere today. There's no industry that isn't making use of artificial intelligence somehow. Even ones who may not be aware of it often have tools that make use of artificial intelligence somehow, whether that's with very intelligent search capabilities, or maybe it's with AI that checks for automation of detection of things like anomalies in your logs or in the values that are coming through your IoT sensors. AI is everywhere, and it's been capable of bringing great business value for a lot of different use cases. But what do we mean when we say AI? For me personally, and for generally, if you're talking to someone from Esri, they'll be talking about anything that is artificially or synthetically capable of learning. So if it can get better at a task, particularly on its own without a whole lot of human feedback, that's something that we would probably consider to be artificial intelligence. And there's lots of versions or categories of AI. You'll notice my kind of favorite Venn diagram over here on the right that kind of has not only these buckets going vertically down, but also these kind of horizontal categories, computer vision, behavioral, natural language. So we'll walk through a few of those so that those terms are familiar to you after this. The two big kind of subsections of AI that you'll hear a lot about are machine learning and deep learning. These describe the underlying algorithms that support artificial intelligence models. So a model is kind of like our very rudimentary brain that we're creating using some code. And these two different types of brains are trained in different ways. Machine learning uses statistics to kind of give itself feedback on how well it's doing at performing a task. And deep learning does the same thing, but there are layers of how it gives itself feedback that are hidden. So that's the difference between machine learning and deep learning. Machine learning, you have complete visibility into how it's giving itself feedback. With deep learning, that's not exactly the case. The network has hidden layers and it's a bit more complex. Some other cross-cutting categories of AI are supervised, unsupervised, and reinforcement learning. These describe actually how the model gets trained. So with supervised, you tell a model, this is the thing I want you to do. These are the categories I want you to detect, or these are the numbers I want you to predict. So the human has kind of a lot of control over what the model is going to output. With unsupervised, you're basically pointing the model at a problem and asking it to go and figure something out. It might figure out something you weren't expecting. It might give you more categories or different numbers than you hoped it would predict. But oftentimes that's kind of a very natural way of figuring things out about a problem that you aren't very familiar with yet. And then reinforcement learning is kind of its own category that's somewhere in between the two, which we won't spend a whole lot of time of. It makes up a very small percentage of the AI that's done today. And then you have a few other genres of models or neural networks like reactive, limited memory, externally aware, and self-aware. Reactive is the most basic. It has no memories. It can't use past decisions it's made to inform decisions it makes currently. Limited memory will have a short-term memory. It'll make a decision and remember what informed that decision so that it's kind of optimized and more efficient. Externally aware can identify that there are other objects that might influence the decision that it's making. And then self-aware is an AI that would be aware of itself. Those last two are not really existent. Externally aware, they're kind of on the cusp of getting something that could describe objects besides itself. Self-aware is, Skynet, kind of the thing people get scared of, and that's decades, if not a century away. Then you have the other kind of functional categories of AI, like computer vision, natural language processing, behavioral. And these don't so much describe how the model is trained or how it does its work, but rather the functional application of an AI model that exists. So with computer vision, you're teaching a machine learning model or a deep learning model to see, to identify objects in imagery. If with natural language processing, you're teaching it to read or to write, interacting with language somehow without being explicitly told the meaning of those words. And then behavioral is its own kind of describing the, it's the kind of AI that exists in video games, right? You have an AI that does certain behaviors or takes certain actions. So that's kind of the general oh, well, there's the other piece that I want to talk about: regression and classification. You'll also hear these terms. They're actually really simple. Classification is trying to, figure something out that's a categorical variable, like this is a truck or not a truck. This is a truck or a car or a van. Whereas a regression is a model that's trying to figure out a continuous variable. So it's usually like a number, where you're going to make $32.6 trillion this quarter. That's a prediction that a regressive model would make. So those are the different categories. These are the ways that AI is trained, how it's used, how it does its work, and the kinds of things that it tries to predict. You'll also see some kind of tools listed over on the right: PyTorch, FastAI, TensorFlow, and those are some of the ways that you can achieve AI today. So what do we mean when we talk about geo AI? What makes a geo AI model? That's basically any model or any artificial intelligence that incorporates geography at some core part of the process of creating an AI. So including a spatial component, where something happened or where you predict something will happen, the movement of something from one place to another, or maybe taking something you see in imagery and identifying the result of that relative to where it exists in the real world. And there are kind of a few different buckets of the way we do that, specifically at Esri, but kind of globally for geospatial AI. You have clustering, prediction, and then kind of the generic identification or extraction. Clustering is about identifying things that are statistically significant, relevant to a neighbor. So you've got a group of values that are in one specific spot, and it's statistically significant relative to all of the other values. So you might think about accidents that have been in one specific area. You can perform clustering to see where the statistically significant hotspots are for identifying accidents. Prediction is fairly simple. You're trying to predict a future value from known existing values. And then identification and extraction, that's kind of the computer vision or natural language side, where you're trying to figure out an object or location, something that exists in your data without having to manually identify it. Advanced site selection is kind of a combination of those three categories. And the way that we kind of make this work at Esri is by integrating with a lot of open science tools and platforms that data scientists are already familiar with, so that you can go through your kind of whole data science process and apply that across a range of different areas. AI and machine learning, deep learning, those are cross-cutting categories that you can use to work with network data sets, to work with tabular or vector analysis, to work with real-time data as to make predictions or classifications as your data comes in, or to work at scale against imagery of some kind, LiDAR, satellite, drone, or big data sets that just don't fit inside your normal database management systems. So that's kind of what you do and the data that you do it on, but how do you actually go about doing AI? There's a kind of end-to-end geospatial AI lifecycle that starts with your data. You capture things from a sensor, a camera, a drone, a satellite. You capture it from real-time sensors, IoT feeds, that kind of thing. And then you bring it into a system where you access that data. You prepare and clean that data to make it acceptable for a model to use. And then you create labels if you're doing supervised training, or if you're doing unsupervised training, you jump straight to the model training, where you've picked out a model, you want to make it actually learn how to do a task. Once you've learned, taught it how to do a task and it does that to your satisfaction, you deploy that model to production and consume them so that people can use that to do what we call perform inference. When you run inference, that's really just the model doing whatever task you've assigned it to do. So if you want it to pick something out of an image and you ask it to pick something out of an image, we call that inference. And then once you've actually got the results of that, you have to take action for it to be valuable, make decisions based on the results that your model returns to you. And so if you think about it kind of in a broad set of categories, you do that entire life cycle, you have these different components that have to exist in your infrastructure for it to work. Data engineering, bringing the data in, getting access to it and cleaning it, visualizing and exploring that data before you perform your advanced analytics, spatial analysis, machine learning, and doing that at scale with big data. Once you've done that, you kind of want to smooth your workflow with modeling, scripting, making it to where that process is automated so you don't have to do it manually every time, and then share and collaborate using the results that you have to make decisions. We've seen this be used in a lot of different ways, particularly in our industry. So one example that we'll walk through today is detecting well pads across a landscape using satellite imagery. So identifying where people are putting their new well pads so that you can keep that track of where people think they're getting their best production for competitive intelligence purposes, or taking GPS breadcrumbs and creating a navigable road network from kind of all of that noise so that you can make quick work of creating a network data set. Or if you've got an operating area or a pipeline where you want to identify new structures that are created within your right of way or your corridor, that you can detect that encroachment and then take action. There's lots of other things that you can do with it, detecting frac ponds or building footprints, whatever is most appropriate for your workflow. If you can see it in an image, computer vision can handle it, and natural language processing, behavioral AI are catching up in a lot of ways as well. So actually walk through one of these situations now. We're going to do evaluate well pad detection and how you might go about identifying new well pads that exist across the landscape. I'll switch over to that. So here I am using ArcGIS Pro, and I have an area of interest that I've defined inside the Delaware Basin. So I want to know kind of where well pads sit in this area. If I don't have access to imagery, I can make use of the Planet Imagery add-in to actually go and search using this area of interest. And I can get immediate feedback inside the application about what imagery is available at various resolutions with various kinds of cloud cover. So I can filter and say, I want my imagery to only have at most 20% cloud cover in a given image. We'll filter down by that. And then as recently as January 29th, I've had coverage of this area at fairly high resolution, and I can preview that imagery and where it would kind of be, make the order, and then actually get access to that imagery. For this use case, we actually used kind of freely available Sentinel imagery from the ArcGIS Living Atlas. And at this scale, you can see well pads across the landscape. You can see kind of the rapid areas of development where people are building their new well pads and construction sites. In this particular instance, we did training on well pads, what we consider to be active well pads, meaning that there was some activity besides the pad itself, and then also frac ponds. And what we're really curious about is change over time. So you'll see the ones that are marked out in yellow had actually appeared over the course of a 2-week difference. So 2 weeks prior to this image being taken, these well pads weren't there. And we want to note those changes starting with a baseline. So to do that across this scale would be nearly impossible with just the human eye. The amount of time it would take to go and manually track which ones are new well pads, which ones are pads that we were already aware of, would be impossible. So we started with a baseline of drilling info permits and the area of interest that we've got. You can see well pads across the landscape. After training the model by taking that imagery and running 3 tools, we used the export training data for deep learning after we created our training data set. We trained that using the ArcGIS API for Python, and then we performed inference. We had that computer vision model go and identify kind of these new areas where well pads have been detected. And if I zoom in a little bit, you'll see some of those results where we had either an oil pad or frac pond or an active pad. Now to actually get to this point was only about 4 lines of Python. And in this case, what we did was take the imagery from Sentinel, export those into what we call image chips, right, which are just tiny little tiles of imagery, showing us kind of small subsections that a model can digest. So that's that export training data, and then you get these kind of image tile chips, which show where the well pads are. From there, we create a model. In this case, it's a single shot detector computer vision model, and train it. At the end of that, we have sample ground truth and predictions. And you'll actually notice that in some of these cases, the model, which is on the right, outperformed the humans who were, marking out where the well pads were on the left. So we've already got a pretty great model just from a few lines of code. And then I can actually take that and go and perform inference at scale with it by sharing it to my ArcGIS portal. So we get this model as a result, and then I can use it just by calling detect objects. It'll go through some imagery that I've given it and make those detections. Now you can do the same workflow kind of in ArcGIS itself. And then as the result, we wanted to have a dashboard that showed the results of our inference so that people can take this and go and make decisions. So I can pan across a landscape and see, all right, these the active well pads, the frac ponds that have been detected since I started running inference. So that kind of shows you the end-to-end GeoAI lifecycle. You get access to your data, you create labels about what it is that you want to train on, train the model, and then use the model to make predictions or inferences. And then you make that work shared and available for others to go and use and make decisions based on. So I think I've run right up against time here, if there are any questions that folks would like to ask.
Thanks, Sam. Oh, excuse me.
Sam, so this is Sam Rosario from Esri. So from the practical side and from the practical point of view, right? If we're in the audience and we're looking at this workflow that you have, which is very impressive and very practical. If I'm sitting there and I'm wondering, okay, so where do I start? Like what would be the first step for somebody that maybe wanted to leverage a solution like this? What would they need to consider from the software side, as well as maybe from what they have to do on their side in order to kind of start in this process and in this road? What will be a practical application or a good place to start?
Yeah, so I'd recommend a few different places depending on the need. In the ArcGIS Living Atlas, there are some ready to consume deep learning models that you can use for certain tasks. Like if you want to detect building footprint extraction, we've gone and done that work for you, and we have models that you can just go and start consuming today. If you want to learn more about this process, I'd recommend our Spatial Data Science MOOC. It's an open online course that if you're an Esri client, you can go and take that, and it lets you study at your own pace and gives you homework so that you get some practical hands-on experience with it. If you have other questions about a specific use case, what you think might be possible, obviously you can come talk to us and we'll be able to help guide you there. So those were two places I'd start, either the ready to use models that will already do a workflow, or maybe you want to get into a little bit of the theory, get some hands-on practice, and we have some educational resources there. Other questions?
Yeah, hey Sam, this is Scott. What do you need from a product perspective to be able to do some of the things you do, or you just showed? I mean, you were in Pro. Is this something that you could do in ArcMap? Do you need any specific extensions?
Yeah, good question. So strictly speaking, the ArcGIS API for Python is what you need, which requires a creator named user. That's the minimum. But that's really for people who are comfortable writing code, who are a little bit more comfortable with the metrics of creating an AI model. Maybe you're on the data science side. So it's kind of a lower level interface for doing that kind of work. For ArcGIS Pro, where it's kind of point and click geoprocessing tools that a GIS analyst is more familiar with, you need image analyst extension. And for the hardware, you'd need a GPU that's reasonably powerful. It doesn't have to be huge, but if you're going to do this work at any kind of scale, you'll need one of those as well. So that's the limit of it. If you're comfortable doing the work, the ArcGIS API for Python, you can go and install that today. If you would like a more familiar interface from a GIS professional's perspective, image analyst is what you're after. And of course, you're going to do that at scale. There are some other options like image server, raster analysis server, that kind of thing. Other inquiries, questions?
All right. Thank you, Sam.
Yep.
And let's see. Our final speaker is Michael Bradman. Michael is a product manager for ArcGIS Workflow Manager. He started his career in oil and gas surveying and GIS in Calgary, Canada, proceeding to work in San Diego performing hydrographic LiDAR surveys, and joined Esri in 2013 to create process improvement and productivity tools.
Can
Thank you,
everyone
Michael.
see my screen okay?
Yes.
Okay. Hi, everyone. As mentioned, my name is Michael Broadbent. I'm the product manager for ArcGIS Workflow Manager. Happy to talk a little bit about some of the technology that we're working on and bringing out and some of the context it can have for the oil and gas industry. So if you haven't heard of us before, we're Esri's solution for making scalable enterprise workflow management systems. We help organizations automate and simplify a lot of aspects of performing and managing repeatable GIS and non-GIS work in an organization. So kind of in a nutshell, we really help try and eliminate and remove a lot of the manual and repetitive work that goes into our kind of daily process and our daily workflows. One of the kind of easiest ways to explain that is just with a simple example. So in the case here for basic data editing, which is one of our most traditional workflows, we have spatial and attribute information changing at a location. Those changes are passed to an analyst who is incorporating them into mapping products, sometimes using a desktop client, sometimes using web. Those changes are reviewed by QA, QC specialists, and if there's any problems, they might route them back to the original data analyst or even to the field for review. And so as a simple process of capturing information, incorporating it and reviewing it, this represents kind of one workflow. And as you change data at different locations, it would keep following through the same process where maybe the people would change and the location would change, the data would change, but it's kind of like a factory. You're following a factory floor model, making a car every time. And so some of the relevant functionality here is you have spatial data that's changing at a location, you have assignment changes through the process, you're integrating with mapping products, you have decision points in the workflow, you can send emails through that, and all of these principles kind of summarize a lot of what Workflow Manager does. The benefits of it are that overall you kind of streamline the production process for everyone, so you have a good understanding across the team of what the expectations are and how to get from one place to another. Those assignment changes through the workflow can help enhance communication. It helps with optimizing resource allocation because as people are aware of the things they need to do, just driven by the workflow, then they can get them instantaneously. They can be notified instantaneously. Nothing's sitting around on someone's desk or waiting in an inbox to be addressed. It helps with improving the data quality and accuracy because it's not people using Excel spreadsheets to monitor their work or keeping it all track in a loose format where it's a central system of information, which helps improve data quality and accuracy as that data can be extracted when it's required and updated in one place. And then kind of what differentiates us from a lot of the other kind of work management and productivity tools out there is we are an Esri product. So we do think about location and how location is a part of work. And that can be very useful when you're trying to do reporting. So showing the status of an area and the jobs that are contained within based on coloring the polygons based on the status of the job. you can have those locations assist data analysts getting to a specific location in the work. They can be automatically extracted into things like GP analysis and whatnot. So overall, we are a product that's been around for some time, probably 15 to 20 years. And but the technology around us is changing. So and our way in which we perform work is changing. So if we look at this example, a lot of work now can start in a web environment. It can move into mobile to say do some of that collection, go to desktop for some review, be sent back to mobile, be pushed up to the web for reporting, and really any combination of these dots is possible. So you can have all web workflows, you can have all desktop workflows, you can have an intermix. Obviously, with the coronavirus situation, we have a lot of distributed workforces. And so how do you interact with and keep everyone track when they're using different devices in different locations? They're not centralized in a specific office environment, for example. So that's kind of the technology that we've been growing towards with a new service-driven architecture that we released this year, and is going to be principally what I'm talking about. We do still have the traditional one as well for some specific use cases. So for the new service-driven architecture, we kind of prioritize around some specific examples of workflows. So one is a submission and approval workflow. So in this case, a request is submitted generally from outside of the group. It's reviewed, some actions are performed to complete the request, and the final product is created. So one of the examples of this is in permitting. So you might have to have environmental permitting or construction permitting. So in general, you might receive a request or make a request for a permit. So there's a submission process. Most often these occur on the web. So having either an app or a widget in a web app to provide the location, some high-level project information, and potentially some attachments. That request has to be validated by someone. So it goes into the organization for review. That could be a manual review. A lot of times though, what's requested of us is more automated assisted review. So you have some GP scripts that run, for example, that can go through and validate for the location requested, actually pull results from the GIS information that organization has on hand. So is it in a protected area? Do we have a permit already on file for that location? Is it related to a different area? Can it proceed, but it needs this extra information from the submitter? And so because of that, there could be a back and forth process between the submission and validation, where some of that is performed automatically and some of it manually. But eventually you will hopefully get to a point where you can accept it, at which point the components of the permit are created and reviewed, and then you can provide the final permit. Another example was in the area of data contribution. So for oil and gas, for example, you might contract out specific pieces of work to subcontractors, and their job is to actually collect some of the information that will feed your GIS or solve a problem for you. And so you need to essentially almost create a submission for them for review. And then you're going to receive a contribution of data. And so the process is the same, except now you're reviewing the data contribution. So that data could be in a FileG database, and it's automatically reviewed for things like metadata. And you could still have the same cycle where you do various degrees of checking on that data before you accept it and start the aggregation process so that it's incorporated, and then those final updates are published. And so creating some supporting technology to build out that process and have it be managed is one of the things that Workflow Manager can help with. I do have a short demo just of our new web application that can show some of that experience. Whoop, I forgot to mute it though. So I'll talk through it. This is our new web application for the server that's integrated within ArcGIS Enterprise. So we've really become kind of a formal integrated part of the ArcGIS environment. Workflow systems can now be created, multiple of them on an ArcGIS Enterprise. So if you have different departments, they can access their own system as an item, all supported within the ArcGIS environment. In this case, we're someone who's actually going to create a submission. So we only have access to what we call the work page, where we can see searches that have been shared to us by the organization. We can see some of the active jobs that were submissions that I made previously, and you can see some of them are in progress. So I've made some requests for environmental review in this case before. We're going to create a new one. So this is an environmental review permit. And this is all out of the box COTS technology. So you're not going to see any customization. This is all just driven right out of the box with the new Workflow Manager system. So we've created a piece of work and the user interface is focused down on it. We're going to collapse that panel and actually start to fill in the details of the submission. So what we've really tried to model it after is more of like a TurboTax style feel. So like completing your taxes is obviously a very involved process, can be quite complicated and overwhelming. Permits and submission requirements can often be quite similar. And so you get to build the workflow to essentially nibble at in bite-sized chunks the submission process and have the workflow guide that experience. So in this case, we're getting prompted to update some basic project information, and then we'll proceed to the next step. The next step is going to prompt us to choose how to define the location for the permit. So we can actually have some options to draw on one type of map or select it from a different map, or actually upload, in this case, a KMZ that would have further actions associated to it. We're going to draw the location. The step changes again, this time to an actual web map that I provided. And I can define the location for where I want the submission to occur. So we're just going to draw a simple rectangle in the map. The GP analysis that would occur after this would basically take that location and some of the preliminary information and then start intersecting it against our organization's existing spatial data warehouse and trying to determine what the next steps are. So it might be pushing back on the submitter for more information in specific areas. In this case, we're getting asked to provide some supporting documentation. But eventually, we'll get to a point where we can submit the review. And so once this submission occurs, we can see that an email was sent probably into the organization notifying them of the submission, probably also to the submitter notifying them that the submission has been successful. And then they can dismiss what we call the job tile and either return to completing some of those existing submissions that were already in progress, or they could close out the app. And so our underlying architecture, feeds this app, but it can also feed custom versions of it. So organizations might take just our REST API and build this into their own internal web applications, or make a widget of it and deploy it in Web App Builder. So that's kind of one example. So you saw out of the box steps for prompting for project information, defining the location, running some GP analysis, asking questions, sending emails, and just routing the work accordingly. Another example is in the area of coordinating and tracking designs for infrastructure projects. This demonstration that I have for you is in the context of telecommunication, but I think a lot of those concepts are going to translate very well to oil and gas and similar infrastructure. We're going to do a demo where we cross multiple different personas. So project managers, engineers, field staff, kind of showing you more of one of those lifestyle cycle workflows that I showed you before, going from the web into desktop into mobile. And so this is another page on our Workflow Manager web app. You can see now that instead of just having the work tab, my user, this project manager, has privileges to see the other tabs that are available in the application. So the manage page and the design page. This manage page is for production coordinators, project managers to kind of see jobs that are in the system, check their status, do different searches, get some preliminary information or look at the extensive job details of jobs that are in the system. So they're able to kind of keep a finger on the pulse. Now we're going to just quickly move over. This will be a fast-paced demo to the design experience, actually building out those workflows. So in the submission and approval, every one of those stages from defining the location and getting the project information was all a step and a step type in a workflow just like that. Now, from the project manager's perspective, we're going to create another submission. So we're actually going to create a request that's going to go to an engineer to work on a design. So in this case, even though I'm in the organization as a project manager, I'm creating a new piece of work. I'm going to define the location where that new design is going to be made. And I can see some of the existing ones that are in progress already. And I'll quickly draw in the community that's relevant in this case. So we're going to proceed. And then for this organization, they actually want to choose a specific engineer to work on it. But I could actually have this go to a pool of people, a group in my organization, so that when they go to use ArcGIS Pro, they can actually pick it from jobs that are assigned to their group instead. So in this case, we're into the desktop portion now after completing the project manager's responsibilities of just creating that submission. We're just taking another tour through that job details panel and more information. And now switching hats, we're going to turn into an engineer. In this case, they got an email notifying them of some work to complete, and they've actually not used the Pro project specifically before. That's relevant to this work. So they got a shortcut to getting access to it so they can open it up and start work. What you're seeing is our new workflow pane inside of Workflow Manager that inside of ArcGIS Pro, I should say, that connects to that service-driven architecture. And with tools in Workflow Manager, they basically set up to get into their job, into their work right away. So we're working in versioning. Workflow Managers change the version automatically. We put in that bookmark of a location in the graphic. We've zoomed you to the location. And in this case, for this demo, there isn't an ArcGIS task to assist you with the work, but if you wanted to, you could have a task pop up for this specific design saying, okay, now you use this layer to draw this step and you're going to make these choices, so we can call tasks very easily. In this case, we're completing the survey. Again, as an engineer, we're going to save some of that work. We're still within the context of that working Workflow Manager job, and a different portion of that was to do a quick look at some of the telecommunication lines that were in the area to ensure that there's clearance and an understanding of what the separation is for that height in particular, specific to their industry. When the engineer is all done, we can close out the step, and then at that point, the engineer could look at other jobs that are in their My Jobs queue and start work. But once that design is complete, it updates the server, which tells the project manager still on the web, because they don't, this one in particular doesn't use a desktop client, that they can proceed with the next stage. This is a new experience for us on the web. It actually is an open app step, so we can launch web apps, whether they're mapping applications, whether they're, in this case, ArcGIS Workforce, whether they're third-party websites. We actually can open them up in the context of Workflow Manager. So still within the job, if you notice in the top right-hand corner, job 18. Now what's going on here is that now with that design in place and the location selected, is that the project manager can go in and assign a field crew using Workforce to then get the field survey complete. So at that point, they've created the workforce assignment from Workflow Manager using that dashboard. And that completes their kind of responsibility for now as the field work is completed. That field work occurs in Esri Field Apps. And in this case, that project manager is going to go back into Workforce just to kind of check on the status manually. This could also be done automatically. And they're also going to use a web app that this organization has to switch over the data version and see what was captured in the field and compare it to the design. And they're going to do some of that design verification just using a thin web app as a project manager to ensure that everything was good. And once they're satisfied, they can, again, complete the work, their responsibility is done. It might progress at that point to the next stage of process within the organization once that design is approved. So as a recap, as a project manager, we walked through some of those initial pages, looking at the status of some jobs, seeing the progress. We also took a look as a workflow administrator just at the actual diagram building experience. So we have a bunch of pre-configured step types that perform different actions, like updating job properties or running GP services. And that's what we use to build these end-to-end workflows. So the nice thing about Workflow Manager is this is all COTS and it's easily configurable. So if you found that you actually wanted to prompt the user for the location of the work at the beginning of the submission and not at the end, if you had made kind of a custom app internally or a custom process, or you'd work with a party, you might not have a lot of flexibility without a lot of coding to kind of to change the order of things. With Workflow Manager, it's just as easy as dragging and dropping those squares on the canvas and reconnecting the arrows. So you have a lot of flexibility to kind of define what your process is, make an adjustment, make some tweaks. As a project manager, we came into the work page of the web app. We made some new work. It's also possible for the project manager, if they did use desktop, to actually make that work inside of ArcGIS Pro. So all that functionality is available. Then as an engineer inside of Pro, we were making that design. So we got given the map, we got taken to the work's location, the version was switched automatically. So all those manual actions that actually eat up so much of our time in the day, all those things were performed automatically by Workflow Manager. And then we went back out and used the new open app step to open up Workforce and assign the field crew. And like I say, this is a really powerful piece of functionality for us, allowing people to make web apps or tie into web pages and have that be driven by Workflow Manager as part of a workflow without the context switching of kind of throwing open a new browser all the time and forcing them to understand. The service-driven architecture that we built is tightly integrated within ArcGIS Enterprise. It's, as I showed, distributed as a workflow item. So every system is a workflow item on Enterprise. So if you have multiple groups within your organization, I should say, and you want them all to have kind of their own work management system, they could create it very easily. We have the web app for administrating those workflows, performing work, monitoring the work, tied into ArcGIS Pro as well, all driven from the same service-driven architecture. And then we have extensibility opportunities with widgets and custom applications by taking more of the architecture of what we've built and extending it into your organization. You did see a bit of Pro. It's not actually released quite yet. It comes out in just a couple months in winter of 2021, or 2020, I should say, not 2021. Its primary use cases are focused on those industries with mapping on the utility network. So using feature layer data sources with kind of light mapping requirements in Pro. So really feeding into that mixed web and Pro workflow use case as well. As kind of a nice little wrapper around everything, when you think about Workflow Manager and you think about kind of your work process and whatnot, here are some of the key features. I don't often like to talk about features specifically rather than as opposed to problems that we can help with. But if you have, you know, a lot of work that's around a location that has some spatial data integration and a willingness to, or an interest to have different groups participate, and they might have different levels of control, and you want to assign the work and notify people, these are the kind of features that you need to support that process. And so these are some of our key features within the Workflow Manager architecture. So here's a few links to assist with getting started, but certainly working with us, working with Tiffany can help with that. We also have some more demos. So 20 minutes isn't a lot of time typically to talk through kind of all the examples or how it could be used, but we do have another demonstration, a longer video that you can watch as well. As well, on our GeoNet page, there's a common FAQ. So if you're looking for comparisons or interest in learning about licensing and things like that, we do have an FAQ from our UC presentation this year. We had a really good turnout and probably about 30 or 40 questions afterwards that we answered and made available for the community. And then here's some additional resources. And because those other presentations finished a bit early, we actually have quite a bit of time for questions. So if anyone has use cases or questions about kind of what you've seen in this presentation, be happy to answer anything that you might have on your mind.
Thank you, Michael. Do we have any questions?
Actually, I did have a question. I was just curious, what is the, right now, what is the biggest area of what is the biggest sector that is consuming this kind of resource right now in your organization? I was just curious about that.
Sure. Most of the highest volume would be in local and state and federal government, so in government, and then utilities as well as transportation. We do have some folks interested in oil and gas, but I wouldn't say it's one of our highest volume sectors. But certainly I think there's a lot of opportunity there, particularly coming from oil and gas and surveying originally. Certainly some of the things I did in that time frame was all around more custom solutions for organizations. And so having something like a COTS-based solution would have actually been quite helpful at the time.
All right, sounds good.
Are there any other questions? Okay. Well, thank you, Michael. I'm going to turn this back over to Phil for the wrap up.
Thanks, Tiffany. And thank you, Cindy, Sam, and Michael for these excellent talks that you guys brought us today. They were really, really great. And so glad that you guys could come and help us and support the PUG. I would also like to say thank you again to Esri for putting this event together and their continued support of the PUG. And finally, I wanted to say thank you to Tiffany for doing such a great job as our moderator. Anybody have any further questions or any comments?
The only one I have for you guys is remember that there are opportunities to speak. So if you're doing some really cool or interesting things and you want to kind of get your name out there and kind of show folks what you're doing, I would encourage you to reach out and to present. We have a few speakers we're looking at for Q1, and as Phil mentioned, it's normally an event that we have at the Gingerman, but because of the current pandemic, we're probably gonna have one more virtual meeting, and hopefully for Q2, we can all kind of finally get together and see one another. So, please feel free to reach out if you're interested in presenting. I thank everybody for participating and coming out. And if you have any questions, you have our contact details. Have a great evening, everyone. Bye.
Thanks, everybody. Have a good evening. Bye.
Have a good evening.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Bye. Thank you.
Well done. Thanks, guys.
Thank
Thanks,
you.
Tom.
Hello.
Bye.
Bye.
Thank you so much. Have a great night.
Thank
Thank
you.
you, you too.
You too.
Thank you, guys. That was great.
Thanks, Mindy.
Thanks, appreciate it.